Can everybody hear me?
We can hear you loud and clear.
All right, I'm going to attempt sharing my screen here. So good afternoon, everyone. I'm Kelly Merrill, and I'm an aquatic ecologist with the Lakes and Ponds Management and Protection Program. And I've had the very great privilege of getting to monitor the status and trends of Vermont's inland lakes for over 20 years now. I will be giving today's presentation along with the Lakes and Ponds Management and Protection Program's manager, Oliver Pearson, who, while new to Vermont, has a lot of experience getting environmental fixes done in places as far afield as Africa. Our colleague, Dr. Leslie Matthews, gave a presentation as part of this series about how Vermont is losing its oligotrophic lakes and about the Vermont Lake Scorecard. And today I'm going to give a brief review of some of those slides for those who missed it and those who like a refresher, adding in our national lake assessment results as well. And I have just changed my screen, very strange. Okay, can you guys, are you still out there?
Yep, we can see you.
Okay, and if you want to, Rachel's going to put in the chat a link to that previous talk that goes into a lot more detail about some of the analyses I'm going to touch on. And then Oliver is going to share with you the approach that we think would afford increased legal protection for our clearest, lowest nutrient lakes, which will help ensure action happens earlier when there is still time to save and more easily restore them. So back in 2007, Neil Kamen participated in the first ever EPA-led National Lake Assessment. Unlike most states, Neil decided to sign Vermont up to participate in what is termed as an overdraw level. His foresight led to our being able to directly compare the condition of Vermont's lakes to those of the nation in various ecoregions around the country, because the methods used were the same at the state level as was across the nation and allowed us to compare apples to apples. In both the 2007 and 2012 US EPA National Lake Assessments, the Vermont Department of Environmental Conservation participated at this overdraw level, sampling a random draw of about 50 lakes. And we plan to do this again in 2022. But what we found from the very first survey when we started comparing Vermont's data to the nation was that Vermont is stewarding some of the best lakes in the nation, which I think we knew as Vermonters, but when you see it in empirical data, it just sort of sends the message home that much clearer. So except for the upper Midwest, Vermont has a higher proportion of natural lakes than the nation in 8 other ecoregions. Much of the nation has artificial reservoirs. In this graph, you see the clear, low nutrient oligotrophic lakes shown in dark blue. Except for the Western Mountains ecoregion, Vermont has a higher proportion of oligotrophic lakes than any of the ecoregions or the nation. In green, you see the mesotrophic lakes in light blue, and then the eutrophic lakes are the ones that are actually in green, and hypereutrophic, which we have very little, tiny little sliver of, those are more common across the national landscape, and that's really, really, really nutrient enriched. So this graph then shows the proportion of lakes in good, fair, and poor condition for total phosphorus across the 9 ecoregions, the nation, and Vermont. And you'll see that with respect to phosphorus, Vermont has a high proportion of lakes in good condition and higher than the nation and about half of the ecoregions. Another study comparing water clarity across 13,328 lakes and reservoirs across the nation found that Vermont had the 4th clearest lakes in the nation. This study looked at Secchi readings to make this determination. Vermont's lakes had a median water clarity of 4 meters. Only Alaska with water clarity of 5.9 meters, Montana with 4.8 meters, and Maine with 4.6 meters have clearer lakes than Vermont. In 2016, a paper came out by Stoddard et al., which published findings from EPA's National Aquatic Surveys. This study showed the evidence that on a continental scale, we are losing our oligotrophic low nutrient streams and lakes. And you'll see the graph on the right is for the nation's lakes sampled in 2007 and 2012. And I'll show you later results from Vermont for that same period of time. But that study prompted us to look at our long-term phosphorus trends. My colleague, Dr. Leslie Matthews, used data from our spring turnover sampling program in a linear mixed effects model, which handles data like ours. On this graph, each vertical line represents a lake. The black dot represents the rate of change for total phosphorus for the lake, and the vertical line represents the 95% confidence interval. The red horizontal line represents no change. When the entire vertical line is above the horizontal red line, that represents lakes that are significantly increasing in total phosphorus, while below the line represents lakes that have significantly decreased. Now the lines are color-coded, or the lakes are color-coded according to their trophic condition in the 1980s. Blue for oligotrophic, low nutrient, green for mesotrophic, moderate nutrients, and red for eutrophic, highest nutrients. We estimated that almost all of the oligotrophic lakes in Vermont have increased in total phosphorus over the last 40 years, as well as many of the mesotrophic lakes. On the other hand, all but one of the high nutrient eutrophic lakes have stable or actually decreasing phosphorus trends. Leslie then took a look at our summer volunteer lay monitoring data, which doesn't go back as far in time as the spring data, and it isn't for as many lakes, but she found the same results for the oligotrophic lakes in this data set as well. All 9 of the oligotrophic lakes have significantly increasing phosphorus trends using the summer lay monitoring data set. So now let's look at the results from the 2007 and 2012 National Lake Assessment, a completely different way of measuring change in total phosphorus levels in our lakes that uses a probabilistic and random draw approach, so you can say something about the entire population of the lakes in the state. In this figure, the plot on the left shows the percentage of lakes in poor, fair, or good condition for total phosphorus in 2007 and 2012. The plot on the right shows the change in the percentage of lakes in each condition, along with the confidence interval for that change. Results are significant when the confidence interval for the change does not cross 0, represented by the black vertical line. In contrast to the results we saw from our long-term study, the percentage of lakes with higher phosphorus, those eutrophic lakes, increased significantly over this 5-year time frame. We also found that the percentage of lakes in good condition for total phosphorus, which includes our oligotrophic lakes, decreased significantly from 2007 to 2012. This result corroborates the results from our long-term spring and summer data sets. Vermont's phosphorus results appear to exactly parallel the National Lake Assessment results for the Northern Appalachian region. The region saw a significant increase in the percentage of lakes in the poorest condition, and it also saw a significant decrease in lakes in the least disturbed or good condition for phosphorus. In 2007, half of the nation's lakes were eutrophic or that hyper-eutrophic, which is the term for lakes with really high nutrients. 10 years later, preliminary results from the 2017 National Lake Assessment find that the proportion has now risen from 50% of the nation's lakes to 2/3 of the nation's lakes being eutrophic or hyper-eutrophic, with only 10% of the nation's lakes remaining oligotrophic. So total phosphorus is increasing on our lowest nutrient oligotrophic lakes. We know this from 3 different data sources collected in 3 different ways: Vermont DEC's long-term spring turnover data set, Vermont DEC's summer lay monitoring data set, and now the National Lake Assessment's probabilistic study results from a random sample of lakes sampled in 2007 and 2012. Vermont's phosphorus results appear to exactly parallel the NLA results for the Northern Appalachian ecoregion and from the Stoddard et al. 2016 paper for the nation. So now what do? The purpose of the Clean Water Act is to maintain and restore the physical, chemical, and biological integrity of the nation's lakes. As we approach the 50th anniversary of the Clean Water Act next year, we can reflect on how far we have come with the restoration aspect of the Clean Water Act. We no longer have rivers lighting on fire. And in Vermont, phosphorus trends on our 4 inland lakes that are or had been listed as impaired for phosphorus have stable or significantly decreasing phosphorus trends shown here in spring and summer trend data in the red boxes. This is true for lakes Memphremagog and Carmi, as well as Tickle Naked and Shelburne ponds. That's 100% in stabilizing or reducing phosphorus in all the inland lakes that have been listed as impaired for phosphorus. So next year, we have a lot to celebrate. But the maintain aspect of the Clean Water Act has taken a backseat to the restore part. And we are seeing the toll that focusing so much of our attention on our highest nutrient lakes has taken on our oligotrophic lakes at the state, regional, and national levels. So what tools are available? Vermont has a set of nutrient criteria in its water quality standards. These criteria were built by taking user perception surveys taken by our volunteer lay monitors while they were out taking their weekly SECI, chlorophyll A, and total phosphorus readings. Eric Smeltzer and Neil Kamen used this data set from Vermont's inland lakes to set nutrient criteria. This was modeled after the approach that was used to set the thresholds for the Lake Champlain total phosphorus, TMDL. They determined that at a minimum, inland lakes need to keep their total phosphorus levels below 18 micrograms per liter. Water transparency or SECI readings need to be greater than 2.6 meters, and chlorophyll A, a measure of algae biomass in the water column, to less than 7 micrograms per liter. Lakes where these thresholds are not met are determined to not meet the aesthetics requirement in the standards. Aesthetics is a use that is legally protected by the Clean Water Act. There are currently 4 lakes in the state listed as impaired for phosphorus. They are Lake Champlain, Lake Carmi, Shelburne Pond, and Lake Memphremagog. They are considered to not be meeting the aesthetic use requirement. The nutrient criteria were set up not to be a one-size-fits-all approach. It sets the minimum thresholds for lakes, Class B2 lakes. So no lakes in the state can have water quality lower than that floor, and all lakes are legally protected to that level. However, recognizing that there are lakes in the state for which that bar would be too low, the nutrient criteria have 3 additional classes of water. Class A2, which are lakes that serve as drinking water sources and hence need to meet higher water quality standards, and what is termed Class B1 lakes. For lakes with low nutrients and really clear waters, there is the Class A1 designation. So here's a way to look at all of this that I think will help illustrate why we'd want to upward reclassify lakes currently meeting Class A1 and Class B1 nutrient criteria and hold them to those higher standards. In 1993, a paper by Carnes et al. Had the original version of this figure in it, which has any ecosystem attribute on the y-axis. In our case, that's total phosphorus. And then chronological time on the x-axis. Here we see the minimum acceptable state, which currently is set the same for most every lake in the state, the state below which we will not let any lake in the state fall. Then there's the maximum achievable state for a lake, which is going to be different for every lake. And finally, we have the actual recorded condition of a lake. This is data from Caspian Lake, and this picture was taken from the sunken island in the middle of Caspian Lake. So for instance, roughly 30 years ago, the summer mean total phosphorus concentration in Lake Caspian was 5 micrograms per liter. Is this what Carnes et al. Would term the maximum achievable state for Caspian Lake? The current minimum acceptable state to protect aesthetic use on most lakes in the state is 18 micrograms per liter, including for Lake Caspian. Over 3 times greater than the historic state of 5 micrograms per liter measured on Caspian Lake 30 years ago. And we have spring phosphorus data going back 40 years ago that shows at 5 micrograms per liter then. Using the current assessment and listing methodology, the mean summer total phosphorus value for the last 5 years on Caspian Lake is 11 micrograms per liter. That's more than twice what the summer total phosphorus mean was 30 years ago, but it's still nowhere near the minimum acceptable total phosphorus nutrient criteria set at 18 micrograms per liter. We see from the Vermont Lake Scorecard that while the last 5-year mean TP is 11 micrograms per liter, The overall trajectory of the phosphorus levels in both the spring and summer are increasing. So at the moment, we are waiting until this lake hits 18 micrograms per liter to list it as impaired for phosphorus. At the moment, action in the form of listing Caspian as impaired for aesthetics or phosphorus won't happen until degradation is so far gone that restoration is likely no longer possible, at least not without interventions in the watershed, along the lakeshore, and then the lake that would be very expensive and likely very unpopular. At the current rate of increase, we might have to wait another 30 years before we trigger legal action in the form of listing it as impaired. Whereas if Caspian Lake was reclassified to an A1 lake for nutrient criteria, then we'd be able to act sooner. It would be listed as impaired when it hit 12 micrograms per liter, which is still well below what it was 30 years ago and what it might be construed as its maximum achievable state for this lake of 5 micrograms per liter. But legal action would happen sooner, triggering requirements to act while there is still time to turn the trends around. In 1995, Dr. Daniel Pauly coined the phrase shifting baseline syndrome, where he put some good thing on the y-axis like water quality, and then time on the x-axis. Now, each generation comes in somewhere on the curve, and depending on where they come in, there begins their baseline for change. The result is that standards are lowered with each generation. So on Caspian Lake, total phosphorus levels were 5 micrograms per liter 30 years ago. They are now twice that, and we need to wait until they are 3 times that to list it as impaired for total phosphorus. If we reclassify it to A1, we'll only need to wait until it hits 12 micrograms per liter, which is still over 2 times what it was 30 years ago, because we'd be using the current condition to set the baseline for the future. But to me, that makes more sense than the minimum acceptable condition for Caspian Lake that is currently 18 micrograms per liter. Now, you'll recall that with only the exception of the Western Mountains ecoregion, Vermont has a higher proportion of oligotrophic lakes than any of the ecoregions or nation. So with respect to the shifting baseline syndrome, the rest of the nation is starting off with lower expectation than Vermont is, but regardless, we too are at the mercy of the shifting baseline syndrome. We want to bend the trend or at least flatten the curve for phosphorus, as we've done for Vermont's inland lakes currently listed or recently delisted as impaired for aesthetics, Lake Carmi, Lake Memphremagog, Tickle-Naked Pond, and Shelburne Pond. Because Caspian Lake is not Carmi, is not Lake Champlain, which is not Memphremagog, which is not Tickle-Naked, we don't set management implications across the board a priori before we list a lake as impaired, which makes complete sense because the phosphorus abatement plan for our impaired lakes need to be tailored to each lake individually if restoration is going to succeed. Similarly, Willoughby is not Rapondo, which is not Maidstone, which is not Caspian, all of which are oligotrophic lakes. So a one-size-fits-all does not work for those lakes we list as not meeting the aesthetic criteria, nor will it work for lakes we list as meeting A1 nutrient criteria. So what's the plan? We try a similar approach to reclassification that we do to listing. We list lakes that meet the nutrient criteria for A1 as A1. This sets in motion the requirement that a protection plan be tailored to the lake, similar to our lake watershed action plans and to total maximum daily loads plans. Here's an example of a step that might make up a protection plan. First, we want to determine where the phosphorus is coming from, and maybe we'd want to figure out a form of total maximum daily load for the lake. And once we have a good handle on where the phosphorus sources are likely coming from, we can develop remedial intervention options and then implement the preferred options. Finally, we'd need to monitor for compliance and effectiveness of the remediation to see if it's working. So on the sleuthing out the sources of phosphorus front, we have a couple of new tools we've developed that will help us do that. Since 2010, we have been conducting 2-day intensive quantitative lake assessments during the summer index period on Vermont's inland lakes. The purpose of these visits has been to monitor the status of the lake, and we hit anywhere between 1 and 50 lakes per year, depending on our program priorities. We have semi-quantitative assessments that go back to 1989, but in 2010, Jeremy Deeds, Mark Mitchell, and I came up with a more quantitative approach for conducting these assessments that borrowed some from the old surveys as well as from the National Lake Assessment Sampling Protocols and littoral habitat assessment approaches. We sample at the deep hole called the index site, 10 sites around the lakeshore, and all the inlets and outlets. These are the parameters we measure at the index site. You can see that as new science emerges, additional parameters are added. For instance, back in 2011, we added total chloride to see if Vermont's lakes are seeing impacts from road salt, something that was showing up in the literature back then. And in 2019, we began collaborating with Dr. Mindy Morales and Dr. Clay Williams at University of Vermont to sample for dissolved organic carbon, dissolved organic matter, and phytoplankton. We sampled the tributaries while we're doing this visit for a number of water quality parameters. And we make observations of any deltas, algae, and the dominant aquatic plants at each tributary mouth. We adopted the National Lake Assessments methods for assessing physical habitat at 10 sites around the lake, so we can calculate the NLA metrics for physical habitat complexity, shallow water habitat, lakeshore disturbance, as well as a few measures from the Vermont Littoral Habitat Assessment methods for assessing embeddedness, percent sand cover, percent shoreland trees, and shading. My colleague, Dr. Leslie Matthews, has taken the results from these surveys and created interactive reports for each lake. We now have over 100 of these for lakes across the state. So, for example, here we'll look more closely at Lake Caspian. And on the first tab, you see the results from our July 29th visit in 2019. Using the EPA thresholds for the National Lake Assessment, we see that for the Northern Appalachian ecoregion, scores good for all the water quality parameters, but it doesn't score very well for the condition of its lakeshore and shallow water habitat. If we move to the next tab, the water quality tab, we can look more closely at the water chemistry results. And across the top, you see how Caspian scores in each of the condition categories. Caspian scores good for total phosphorus, for total nitrogen, for chlorophyll A, which is a measure of algae density in the water column, for alkalinity and dissolved oxygen. The graphs below show depth on the y-axis and the surface of the water on the top, and with the deeper waters in the bottom. Since these are summer lake assessments, we are shooting to hit them when these lakes are stratified, if they stratify. The blue line denotes temperature, and you see that the surface is much warmer than the deeper waters. The horizontal line denotes what limnologists call the thermocline. Here we see it at about 7 or 8 meters depth. That's where there is the greatest change in temperature. When strong thermoclines form, this often prevents surface waters and deeper waters from mixing. The green line denotes chlorophyll A readings taken with a meter in the field. And chlorophyll A is a measure of algae density and is very low and fairly uniform throughout the water column, as one would expect in a oligotrophic lake. The black line denotes the dissolved oxygen in the lake, which peaks just below the thermocline. This is often associated with oxygen that is produced by algae generating more oxygen as they photosynthesize. Of particular note is that the readings at the surface are around 8.3 milligrams per liter of dissolved oxygen, whereas right above the bottom at 43 meters, the oxygen levels are only 4.4 milligrams per liter. In some lakes, low dissolved oxygen in the bottom waters can result in the release of legacy phosphorus that was delivered to the lake from historic land use practices. But special studies are needed to determine if the sediments are a net contributor to the lake's phosphorus load, something that could be done if there was money available, say, because it was listed as impaired. But we can look at evidence from our profiles to see if that is a possibility. Conductivity is one screening tool, and here we see the conductivity values don't jump up at the bottom, suggesting that maybe the sediments are not playing much of a role, because higher conductivity levels usually indicate that solutes are being released from the sediments. But if we look at the nutrient data we have from this one-time visit, we see that the total phosphorus levels shown in red and the total nitrogen levels shown in blue, that there is less of both in the surface waters than in the bottom waters. and that for phosphorus, there's almost twice the concentration near the bottom than at the surface. So next, let's look at chloride levels. We know that in lakes that are not impacted by road salt in Vermont, that chloride levels are below the detection limit of 2 milligrams per liter. However, we see that Caspian's levels are well above that at 7 milligrams per liter. So the lake is receiving road salt runoff. The good news is that the levels at the bottom of the lake are the same as at the top, and hence the lake is not becoming permanently stratified, something that has been observed in Adirondack lakes. If we move to the inlets tab, we see that the levels of chloride are elevated in some of the streams as well. While tributary number 1 is at the detection limit, tributaries 4 and 5 are well above the detection limit and suggests that road runoff is making its way into the lake in the form of road salt from these 2 tributaries. If we look at the total phosphorus readings we had in the tributaries during this visit, we see they are all higher than the overall summer total phosphorus mean for the lake of 11 micrograms per liter, with tributary 6 having the highest concentration. Now, conductivity in the lake runs about the concentration found in tributary 1, but all the other tributaries have much higher conductivity readings than the lake. And there are a number of tributary parameters that folks can toggle through, like lakes, like sediment delta area, aquatic plant cover, the depth of the sediment delta, turbidity, and width. These can all be used to help hone in on tributaries that might need more sampling as part of a lake protection plan to determine where the sources of phosphorus might be coming from. Now, if we move to the habitat tab, we see how the lake scores using the 4 national lake assessment metrics for habitat. Lakeshore disturbance is a measure of how intensely the nearshore is used, and we see Caspian scores fair for this metric. Lakeshore habitat is a measure of the canopy, understory, and ground cover, and we see Caspian scores poor for this. Next, we see that the shallow water habitat scores is also poor, and finally, the score for physical habitat complexity, which is a measure of the combined lakeshore and shallow water habitat, is also scores poor. Using the checkboxes on the map, you can explore some of the parameters measured, like embeddedness, which is a measure of how buried rocks are, presumably due to runoff from nearshore development. If we look at the habitat comparisons tab under habitat, we see how Caspian Lakeshore compares to undeveloped shorelines shown by the blue bars and to unbuffered developed shores shown in the red bars. We see the condition for embeddedness, percent sand, shading, and trees on Caspian aren't as good as undeveloped forested sites, but they're not as bad as our poorly developed lakeshore sites in the state as well. And then under the protection classification tab, we see how Caspian scores according to the Vermont Lake Protection Classification System. And while it is not a wilderness or wilderness-like lake, it does have 2 features that are unique on a statewide basis: natural beach and scenic bottom, which if you've ever snorkeled around the sunken island on Caspian Lake, you will understand what the definition of a scenic bottom is. And then the final tab lets you look at any of the data collected during the visit. We're still planning to add crayfish, diatom, macroinvertebrates, seki, earth metal, dissolved organic carbon, and dissolved organic matter data to these reports, but this is the current working version. And we plan to put these up on the web in the coming weeks, so stay tuned. So the other new tool we have to help sleuth out sources of phosphorus and that could serve as a starting point for a lake protection plan for a reclassified lake is some analysis that Colin Dowie has been doing using GIS. Thanks to the UVM Spatial Analysis Laboratory with funding from the Lake Champlain Basin Program and Vermont DEC, Vermont is the first state in the nation to have land cover resolution down to 0.5 meters or 1.6 feet. Using this new layer, Colin Dowie of the Agency of Digital Services has created summaries of land use at the watershed, tributary, and lakeshore levels. So Colin's reports summarize land uses within the entire watershed, For the 100-foot buffer adjacent to the tributaries draining into the lake, which is really only possible now with this high-resolution data set, as most previous land cover available in GIS is only to the 30-meter pixel size, and hence doesn't get at that detail of disturbance that happens in this very narrow band that is so ecologically important to our waters, that riparian area. Then there is a summary of the land cover in the 100-foot buffer around the tributaries as well as the lake shore combined. And then he has a summary of just the 100-foot buffer around the lake. And finally, there's a summary of the 250-foot lakeshore buffer, the area covered under the jurisdiction of the Shoreline Protection Act that passed in 2014. All of these are included in one PDF for each lake, and Colin is working toward creating these summaries for all lakes greater than 10 acres in the state. Once these summaries are complete, we will be posting them to the web as well, so stay tuned for that. So let's just take a look at what these summaries have to tell us about Caspian Lake and where the potential sources of phosphorus might be coming from. At the watershed level, impervious surface make up only 2.5% of the land cover, or roughly 90 acres, whereas agriculture makes up 781 acres, or 22% of Caspian's watershed. Yet when we look at human disturbances within the 250 feet of Caspian Lake, impervious surface makes up 10% of the area, or roughly 16 acres, while agriculture only makes up a lower percentage than it did at the watershed of only about 5%, or only 9 acres. Meanwhile, if we look at the land cover within 100 feet of the tributaries draining into the lake, only about 2% is impervious surface, or 5 acres, but 25% of the tributary buffers are ag, totaling 70 acres of ag within 100 feet of the tributaries draining into the lake. And with that, I will pass this on to Oliver, who's going to get into the exciting parts about how this is all getting implemented and where things are going in some of our outreach.
Great, thanks very much. Kelly's done a great job explaining some of the threats facing our lakes in Vermont and has provided us with some ideas about how to use spatial analysis and other tools to better understand those threats and develop targeted responses to reverse any negative trends that we are seeing. So I'm going to shift gears and talk about a few tools we're working on with lots of partners to enhance lake protection in Vermont. So why the focus on protection? Well, I think we saw from Kelly's work that we're in the danger of losing some of our oligotrophic or low nutrient lakes in the States. And other threats to our lakes are also increasing, unfortunately. We have statewide data showing that there's increasing frequency of cyanobacteria blooms, as well as increased variations in water levels at many of our inland lakes. We know there's increasing urbanization in Vermont statewide and very focused pressure on our lake shores, which are actually some of the most densely settled areas in the state in terms of houses per unit area. The density of lake residences in Vermont is more than double that in the urban areas of the state, which indicates that Vermont's lake shores receive some of the greatest amount of development pressure of any land area in the state. And that pressure is increasing. We had a record number of Shoreland Protection Act permit applications in 2020, and we were on track to beat that record in 2021. And so what this graph shows is, here in 2020 was our 302 permit applications for Shoreline Protection Act, which is more than we've ever received before on an annual basis. And already for the first 5 months of 2021, we're at 162. So we're on track to break that record in 2021. These applications are typically for development projects in the protected shoreline zone around the lake, from the mean water level inland 250 feet. And more people and businesses are trying to expand homes around lakes, expand businesses up to the limits prescribed in the Shoreline Protection Act, but that'll mean more impervious surface and more vegetation clearing. We know that unbuffered lakeshore development has significant adverse impacts on lake water quality and aquatic habitat, and so we're trying to take action to protect the best of what's left and restore water quality where it's deteriorating. So I'll just speak briefly about two relatively new approaches for lake protection in Vermont: lake watershed action plans, and then reclassification to A1 status, which Kelly's already talked about a little bit, using the Vermont water quality standards, aesthetic use, and the combined nutrient criteria, which is associated with that. So starting out with a lake watershed action plan in Vermont, we define this plan as an assessment process to identify the highest nutrient and sediment pollution loading from a lake's watershed that result in water quality and/or habitat degradation. The Lake Watershed Action Plan, or LWAP, which is our acronym, not a great one, that can then result in a prioritized list of projects and strategies to address the sources of pollution that were identified in habitat degradation. And through these plans, we try to identify recommendations to preserve natural features and functions of the landscape, encourage low impact green stormwater infrastructure, and maintain the aesthetic and recreational uses of lakes. And really the goal of these plans is to come up with this list of projects which can feed into our DEC watershed projects database and then be considered for Clean Water Initiative program funding. So it's a plan that's supposed to identify projects which then get funded to reverse trends that we're seeing in water quality on these lakes. So as I said, this is relatively new for Vermont. We've completed these plans or are close to completing them on 3 lakes, Eden, Elmore, and Dunmore, with a lot of work from the Lamoille Conservation District and those 3 lake associations. DEC just awarded a grant to the Essex County Conservation District to develop 2 more Lake Watershed Action Plans at Maidstone and Fairleigh. And the Lake Champlain Basin Program is in the process of awarding grants for 4 additional plans at lakes in the Champlain Basin. So we're hoping that this tool becomes a useful assessment tool to identify the stressors to the lake and then how to address those through projects. And it's really a participatory and consultative process involving a multi-sector assessment, but done in close collaboration with the Lake Association, with municipal authorities and other local stakeholders. And sometimes consulting firms provide expertise to support the process as well. There's 3 core elements to these Lake Watershed Action Plans, typically a focus on shoreland, given the intense development pressures there and contributions to phosphorus and sediment loading to the lakes from impervious surface, roads, and tributaries. And where tributaries are draining agricultural lands or silvicultural lands, we pay specific attention to potential non-point source pollution from those sources. And the plan is meant to really answer the question of what are the greatest threats to lake conditions, water quality, and habitat. These plans are at a smaller scale than DEC's tactical basin plans, but can contribute to broader goals that the state has set. For example, plans in the Champlain Basin can contribute to meeting phosphorus reduction targets. So taking the example of Lake Caspian that Kelly mentioned, the folks up at Lake Caspian have applied for and received funding to develop a Lake Watershed Action Plan around that lake, so they can look more closely at the 70 acres of what's been classified agricultural land within that 100-foot buffer of the tributaries, in this area here, draining into the lake. And then they can also focus on the 10% of the 250-foot buffer around the lake that's been classified as impervious surface, and really use this data to target interventions around Lake Caspian to reduce the significantly increasing total phosphorus trends that we're seeing there. So that's just an example of how this great new spatial data can support planning and reversing some of these negative trends. So, we haven't developed a plan yet for Lake Caspian, but some of the potential remedial intervention options, just based on what we know, could be additional support for the LakeWise program, which is a voluntary program working with shoreland property owners to implement lake-friendly practices, incentivize septic upgrades to the extent that there might be old and aging septic systems that are contributing phosphorus into the lake, employ some of the tools within the Shoreline Protection Act and the Municipal Roads General Permit that reduce existing runoff from roads. And then finally, looking at tributaries, roads, agriculture, forestry, and all the different land uses. Again, using this new spatial data will be helpful to reduce runoff and non-point source pollution from those sources. Shifting gears to talk about lake reclassification under the Vermont water quality standards. Kelly's touched on this a little bit, but just for folks who aren't familiar, the Vermont water quality standards, which is a state document derived from the Clean Water Act, establishes designated uses, management objectives, and minimum criteria for all surface waters in the state, with these different classifications for each designated use, which I'll talk about in a minute. So some of the uses are aquatic biota and wildlife that are present in our public water, our state's waters, aquatic habitat to support that biota, recreational uses of waters are designated uses under the Vermont water quality standards as well, such as swimming, boating, and fishing. Kelly spoke about the use of waters for aesthetic conditions or aesthetic uses, and finally the use of water for public water sources or irrigation. So those are all the designated uses of the waters of the state under the water quality standards. And each use has 4 possible classifications, ranging from A1 or excellent down to B2 or good. And Kelly touched on that a little bit as well. So most waters of the state are B2. Any water below 2,500 feet is classified as B2 or good, as sort of a point of departure. And it stays that way unless it's specifically designated via reclassification as a higher classification, A1, A2, etc. The state did make the effort to classify all waters above 2,500 feet as Class A1. That was many years back when there was a lot of ski area development going on, and there was an effort to protect those waters during that period. And really what's important with this is all waters must continue to meet their classification criteria as defined by the combined nutrient criteria, which Kelly mentioned, I'll get to in a minute. Otherwise, they're listed as impaired, and a restoration plan must be implemented. One of the interesting things with the combined nutrient criteria for using the aesthetic uses and the associated phosphorus concentrations to classify lakes is that it has to come from data collected during the summer months as per the Vermont water quality standards. So we can use the next generation lake assessment data collection efforts that Kelly spoke about, or we can use our Vermont Summer Lake Monitoring Program data to assess where lakes are on this sort of paradigm of classification, and then consider which lakes are below the lowest B2 standard and therefore require restoration efforts, and which lakes have better water quality as evidenced by lower total phosphorus concentrations and are therefore eligible for reclassification to a higher standard. So that's just one example of how we're using another data source, our Summer Lake Monitoring Program data, to help us with lake management in the state. So Kelly's already showed you this chart in the upper right here. This is the combined nutrient criteria, which associates total phosphorus concentrations and phosphorus response variables like Secchi and chlorophyll with the different classes. And really what we're trying to do now is use our lake monitoring program data, our summer lake assessment data, to determine which lakes are currently meeting or failing the B2 criteria, but also more importantly for this protection conversation, which lakes are exceeding or meeting the B1 or A1 criteria, and therefore which lakes are eligible for upwards reclassification. So that's one of the newish protection tools that we're beginning to roll out in the state. So using the example of Lake Caspian again, what we have in the table and in the lower half of the slide is our summer mean values since 1979 for total phosphorus, Secchi, and chlorophyll A. And you can see that all these values exceed the requirements for the A1 threshold for Lake Caspian. And so that begs the question, does A1 classification better match our expectations for Caspian's aesthetic use? And is 12 micrograms per liter of total phosphorus a more appropriate threshold for impairment? And so, for us, the answer to that is yes for both questions, and that is sort of motivating us to consider reclassification to A1 status for Caspian. So, there's a few important questions around reclassification that we've been trying to answer. First, how does reclassification increase lake protections? That doesn't guarantee by itself that total phosphorus levels won't be exceeded. It does put into place a mechanism for action sooner when we hit that lower threshold for impairment, when more likelihood of restoration success could be achieved at much lower cost. And Kelly explained that in great detail. Reclassification would also give a lake the tool of legal requirements that come with listing a water as impaired, and helps make funds available sooner for restoration work, which I'll talk about in a minute. And these increased protections are afforded to a lake that's been reclassified, even if no additional management implications, management restrictions, or legal protections are afforded to a lake through the reclassification process. Another important question we get a lot is, well, what are the management implications of reclassification? If I'm a shoreline property owner or have a business in a lake watershed, if we reclassify, what does that mean? What will I not be able to do anymore? And so there are some existing prohibitions in Vermont on the books for Class A waters, and they mostly have to do with discharge and waste management. But I think the key one that we focus on the most is this middle one. That in an A1 watershed, you cannot have an indirect discharge system or a septic system with a design flow greater than 1,000 gallons per day. That's 1,000 gallons per day is quite a lot. That's a 10 or 11 bedroom residence before you get up to 1,000 gallons a day. So for your typical camp owner, 1,000 gallons per day is well above what they need. Whereas a business, a summer camp, a state park is going to have a septic system greater than 1,000 gallons per day. Any existing ones are of course grandfathered in, but any new septic systems would be prohibited based on this existing legislation. So there are some existing prohibitions in a Class A watershed, and it's important to note that when you reclassify a lake to A1 status, that includes the lake itself and also any of the waters in that lake watershed, any of the tributaries flowing into the lake. Some possible new management implications for A1 waters. This is very much a question at this point. We believe that for lakes with significantly increasing total phosphorus trends due to external nutrient loading, such as Caspian, requiring riparian buffers on the tributaries, it could be a good idea. There might be other possibilities, providing some financial incentives for use of silvicultural accepted management practices or agricultural best management practices in the watershed, or limiting the exemptions to ban on winter manure spreading. I think folks are aware there's that ban on winter manure spreading in the state, but frequently exemptions are granted, and maybe in an A1 watershed we'd say no exemptions. But those are just ideas, and those will have to be discussed further and viewed on a lake by lake basis. So sort of trying to wrap up quickly here, when listing a lake as impaired, as Kelly has said, we list the lake based on the evidence that the lake is failing water quality standards. And then once it's been listed, we then decide through the TMDL development, what are the specific interventions needed to address the source of impairment, typically phosphorus, based on that lake's unique characteristic. So we're proposing a similar approach for reclassification, develop a lake-specific protection plan, or possibly using the Lake Watershed Action Plan model to establish A1 protections, most of which would be voluntary through projects, and then where there is any new restrictions, enshrine those through the rulemaking process. So, what will reclassification offer to a lake that it doesn't already have? As we've mentioned, action sooner by raising the threshold for impairment, developing these lake-specific protections, possibly via Lake Watershed Action Plan. And then we like to think that a lake that's been reclassified to A1 will sort of have an elite status and have enhanced access to some of the funding that's out there to support water quality enhancement work in Vermont. So that could be Act 76 and the funding that the future clean water service providers will be managing, QIP funding from DEC, and possible Lake Champlain Basin program funding for lakes in the basin. The thinking there is, these lakes will be with an A1 classification, sort of an elite lake with this unique status. And in our effort to protect the best of what's left, it might be worthwhile to give them some special consideration for the funding that's available for these types of projects in the state. So in terms of our next steps on reclassification, this is our last slide. We are aware that under Vermont water quality standards and under legislation in Vermont, reclassification can be initiated by Vermont DEC or via petitions from the public. And so far, we believe there should be strong local support for any effort to increase the classification status for a given lake. And so we're looking to petitions from the public to initiate the reclassification process. And this is not really a new idea, reclassification to increase lake protections, but it's only been done once in Vermont about 5 or 8 years ago for lakes in wilderness areas within the Green Mountain National Forest. So we haven't reclassified lakes that have residences and businesses and people living around them. So that's why we're referring to this as somewhat new. So Vermont DEC has begun outreach to interested and eligible lake communities and municipalities and towns about lake reclassification. For the moment, we've identified 7 eligible lakes based on their total phosphorus concentrations, meeting that A1 threshold. And most of these also have increasing total phosphorus as well as active lake associations. And so those 7 lakes are listed here. And we've had discussions with members of lake associations, select boards, municipalities, other local stakeholders about the lake reclassification process. There is substantial local interest, but lots of questions and some concerns over the management implications of reclassification. We're also exploring reclassifying some lakes for fishing uses to generate additional support. Many of these 7 lakes also meet the requirements for A1 or excellent fishing uses, and bringing that into the fold might get more public support given strong local interest in angling from that community. We expect some petitions this year to reclassify high quality lakes to A1 status. Petitions then kick off a rulemaking process that the state or DEC leads, involving public hearings, some internal decisions about how to proceed, eventually legislative committee review, and finally a decision. So that's what we're hoping to see over the next few years vis-a-vis using this reclassification tool to increase protections for lakes. So with that, we'd like to thank you very much for your attention, and we'd be happy to take some questions.
Awesome. Thank you so much, Kelly. That was an awesome presentation. We've got a few questions in the chat. First, I'd like to mention that we will be sharing a PDF version of the PowerPoint slides, so all the links and stuff, you'll be able to find those. And also, I direct anybody to the chat. Kelly has been posting some awesome links, so if you want to explore some of those, that'd be great. One of the first questions we have is, are tile drains contributing phosphorus, nitrogen, and/or silt to the Caspian Lake systems?
I mean, I can say that we haven't done that analysis yet. It's a great question. You know, we know we've done more of that type of analysis around, you know, lake like Lake Carmi, where we're doing very intense monitoring because that's a lake's in crisis, and we're looking at dissolved phosphorus coming in, and a possible source of dissolved phosphorus is tile drains and the water flowing through those tile drains into tributaries. So, you know, we would need to do a similar assessment of how many tile drains there are, how many agricultural fields with tile drains there are in the Caspian Lake watershed, and then do some targeting monitoring of both total phosphorus and dissolved phosphorus and try to differentiate those different types of sources. So I guess the best answer I can give you, Rob, is possibly, but some additional analysis would be required to confirm that. I don't know, Kelly, do you want to add anything to that?
No, that would be something that, you know, would be something that I could see with increased funding of some sort that could help to do that type of analysis to find that out. I don't know the answer to that question.
Great, thank you guys. We have a question from Kelly Stetner, who's one of our call-ins. She asks, the septic system limit of 1,000 gallons per day. I understand that Oliver said any existing systems are grandfathered in, but are any special considerations being looked at to more effectively monitor those existing systems and/or migrate any suspected impacts? And I can repeat that if you need.
Well, I think maybe Oliver, bringing up the stats we just got, I think there aren't very many of those systems permitted that immediately discharge to inland lakes. I think maybe 5 lakes in the state, inland lakes of roughly, have a system that is currently discharging, none of which are these oligotrophic lakes that have increasing trends.
Yeah, so Kelly, you were referring to systems greater than with a design flow greater than 1,000 gallons per day, and you're exactly right. You know, if Kelly's question was about smaller, you know, existing camp systems, you know, there's been some large lake studies, and Kelly's more familiar with this, that show that overall septic systems contribute a relatively small amount of phosphorus to the lake's total phosphorus balance. But you know, with these oligotrophic lakes where we're seeing increasing trends, every little bit counts. And you know, so DEC through the LakeWise program has tried to engage lakeshore property owners, as you may know, Kelly, about, you know, understanding how their septic systems work and understanding that they fail or deteriorate over time, and making resources available for studies and in some, you know, limited cases, unfortunately, you know, support for septic system replacement. So I think it's part of our playbook when we're looking at, you know, what are the external sources of phosphorus to a lake, particularly a oligotrophic lake, and how we can use different tools, you know, such as tracers, dyes, caffeine, et cetera, to see to what extent septic systems and household water use is contributing phosphorus to the lake. So that's something we can do where we have, you know, a lake of interest to see if there's any possible contributions from smaller household residential septic systems.
Awesome, thank you. People can continue to ask questions in the chat. We do have a couple of raised hands. I can call on John Windus to unmute, and please feel free to speak your question.
Hi, thanks Kelly and Oliver. This was a real tour de force. Great information that you packed into, felt like I was getting a drink from a fire hydrant. It's going so quickly. I think I'm going to have to play it back at 3/4 speed to get it all in. I think the approach you're taking makes great sense in terms of trying to prevent problems before they become too large. And I think in particular, the approach that Kelly and her colleagues are doing in terms of identifying the sources is terrific. I have two comments that I think have some major potential implications that I'd like to get your comments on. It looked to me like the tributaries were contributing at least higher phosphorus and maybe some of the other nutrients. Yet there's only a 100-foot riparian buffer. For lakes, we have 250 feet. It makes no sense to me if that's where the problem is, or at least a major contributor, and I might think that from what the data you showed, why we don't have a higher riparian border around these streams and tributaries to what we have to the lakes. So that's one point. The other point I'd like to have you make is that even though Vermont is not the Wild West, we have a lot of visitors that come in and use our Airbnbs, which are on our lakes. And so these facilities are private homes that have septic systems on them, which have been based on permits for who's living there. And I'm not sure that I agree that the advertisements for these places that are advertising, 20 or 30 people with sleeps is what these homes have been designated for in terms of what their septic system can manage. And so I'm concerned about this and wonder, whether there's evidence that this is a problem or could be a problem. So those are my two big points.
It's 1 o'clock.
Recognizing it's 1 o'clock and folks need to go, I'm happy to stay on and answer John's question as well as any other. It looks like John Barrows has a question as well. I don't know if that's okay, moderators, for us to do that. Okay, fabulous.
Thank you.
So with respect to tributaries, Jack, there is no, unless a town has enacted, to my understanding, unless a town has enacted buffer protections for tributaries in their local zoning, there is no statewide requirement for vegetative buffers along streams, including the tributaries draining into these lakes. What was presented is the mapping of 100-foot buffer, just to get a sense of how intensively, those buffers are currently altered, but not necessarily advocating, that that's the smallest buffer you want to go with. And with respect to the Shoreland Protection Act, and I'll let Oliver correct me if I get this wrong, the 100-foot, there's the 250-foot jurisdiction of the Shoreline Protection Act, but it allows building within that 250-foot, but that 100-foot buffer between the lake and the structure, there's vegetative requirements for that. But I agree, and that, the tributaries have, and that's what these mapping that Colin has done, that's awesome. And that we have this half-meter resolution, first in the nation to that high resolution. We can look at what is the existing condition of these tributaries. Has not protecting those buffers really had deleterious effects on our, waters? Can we focus restoration efforts there and further protection efforts in the future? To the Airbnb issue, you're exactly right. There's been someone up on Willoughby, and his name is escaping me now. Maybe Ethan will be able to remember, but who has retired head of limnology at the University of Wisconsin. He has been bringing up that issue of Airbnbs for many years, where you have people planning a family vacation, they bring everybody, this is the big event, they're going to get together for a whole week, and it's 30 people in a camp that was, the septic was designed for a family of 4 to visit occasionally. And it is something that we've been working with our, our outreach on, trying to do septic socials. Some lake associations actually have, you know, little cocktail parties around the open septic, so they learn about how to actually manage those better and protect, and actually, you know, so that they won't fail, and are getting education out to that.
Yeah, Kelly, I would just say, you know, to the first part of Jack's question, what's great with riparian buffers in Vermont is that our silvicultural accepted management practices and our agricultural best management practices and our Act 250 and Act 248 permits all have some buffer guidance, and in some cases buffer requirements. But what we don't have in Vermont is a statewide unilateral, you know, basic requirement or minimum requirement for vegetative buffers, sort of like what the Shoreline Protection Act did when that was passed by the legislature, you know, 5 or 6 years ago. So we see plenty of tributaries to Vermont's lakes that are not buffered, even with even 50 feet on either side, and that's why it's something that we're thinking about as a potential requirement for tributaries draining agricultural, silvicultural lands, and maybe even more, you know, developed and impervious lands that have some sort of minimum buffer requirement. That'll be an uphill battle, and you know, there's probably some categories of land use where we can't do that, where we can't require that, but that's something to think about. So, and then, you know, Jack, to your second point, you know, I think it's a very valid concern, and to the extent that these household septic systems are permitted for one design flow based on one number of bedrooms with certain assumptions about usage, and then short-term rentals are blowing those assumptions out of the water, so to speak. That's worth taking a second look at, both at the state level, so we can begin to look at that. And thanks for your email on that subject, Jack, as well as at local and municipal levels. So thanks for raising that. We can get back to you on that one. I think we have a question from John Barrows.
Yeah, thank you. John, you have Barrows, please feel free to unmute yourself and ask your question.
Can you hear me okay?
Yes.
Oh, great. Yeah, I probably have 100 questions, but I'll try to stay the focus on the buffers. I drive by, I've been involved in water quality as a amateur for about at least a couple decades. And I drive by and I notice how farms are developed. And I went by a farm yesterday in Williamstown. It was a nice farm, organic farm, but it's on the side of a hill. And there's a stream at the bottom of the hill, of course. And you can find so many farms that fit that description in Vermont, right near a stream or a river or a ditch that goes right down to the stream. And the cows, of course, were outside the barn and on the side of the hill. And you could see where, and it's not within your 100 feet. It was probably 300 feet. But the 100-foot buffer, you know, you're looking at it on the side of a hill doesn't really mean anything. So there's situations where, and I drive by and I see the buffers on fields, active crops that farmers are growing, and it's a grass buffer which can actually legally be cut down. And so then when it's cut down, there's no buffer. So the whole buffer thing is I don't think how accurate you can measure your buffer systems. I think they should be wider and bigger and fit the site rather than just a general rule. I don't think a general rule fits well at all in this case.
Well, John, just to your point about the buffers, so one of the things that I did not mention in this presentation was that we went to our colleague in Maine who works for the Maine Department of Environmental Protection Lake Program and asked him for their Maine's 40 years of phosphorus data on their inland lakes because they have a similar data set to ours. And Dr. Leslie Matthews ran the Maine data set through the same mixed effects model that she ran Vermont's data through. And 0% of their oligotrophic lakes have increasing phosphorus trends. Now, we do not know why, and I'm just going to be postulating here. And we have part of the reason Colin is doing this, has been doing this mapping work, is that UVM Spatial Analysis Lab, with a grant from the Linalac Foundation, has gotten a grant to map those Maine lakes, the oligotrophic lakes in Maine, to that higher resolution, 1/2 meter resolution level. And we're going to, so for over 40 years, Maine has protected its tributaries with buffer requirements. And so we're going to look to see if their tributaries and their lake shores are in better shape, essentially have less human disturbances in the immediate riparian areas, to see if that might help explain why they're not seeing increases in phosphorus, but we are. So stay tuned for that. That hopefully we'll be able to finish that work sometime this year.
Can I respond?
Yeah.
Yeah, it's kind of like you said earlier in your lecture. One size doesn't fit all. Each lake is different. Well, each farm is different too, depending on the soils, depending on how the topography. There's a lot of factors, and I don't think a general rule really fits. And I've known throughout the years, according to your basin plans, you've already identified the problem areas in ag and in other areas. You've already done a lot of that work. I'm really glad you have the high resolution and you can do it on a map instead of actually going there. But I think there's nothing better than going to the site and actually seeing it. And it's different than looking at it on a map.
So, I mean, John, it sounds like you're advocating that we take a more farm specific approach to buffer design and look at the unique characteristics and come up with something that would be a more effective barrier to phosphorus, nutrient, sediment loading to those tributaries. And I think you're factually, technically, you're correct, and I agree that there's buffers and there's buffers, and a vegetated woody buffer that's 100 feet wide on the other side of the stream is quite different from a 50-foot grass buffer in terms of its ability to slow down surface water flow, stormwater runoff, and reduce nutrient loading to those streams. I think what we should be doing, as we identify these high quality, low nutrient waters that Kelly mentioned in the presentation, and our next generation lake assessment approach, where we're looking at tributaries, is collecting that inlet nutrient data and showing what's coming into these lakes and how is that contributing to the increasing total phosphorus trends, and helping make the case for enhanced buffers to reduce loading to our lakes. So I think that's something that's within our mandate, if you will, within DEC Lakes and Ponds program. And I think if we can use that data to then make the case for enhanced buffers where needed, that would be great.
Yeah, just to take it a step further, I think there's some areas that are so sensitive that they just shouldn't have pesticides and fertilizers and manure spread on them. They're just, take for example, a floodplain. So I see farmers planting on floodplains, and then the next spring I'll go by and I'll see not this year, but in other years, the field is flooded. So why do we even allow crops to be grown on floodplains? I don't really get that part. And in sensitive wetlands, and I think the farmer should be compensated if the state purchases that land. I'm not blaming the farmer, but the state is allowing manure, pesticides, everything in that manure pit, whatever it is, God knows what, is going on to that field. So I think a lot of times we'd be better off, instead of building new heifer barns, which I see all over the state, and trying to increase the amount of dairy farming. In some instances, we should, in certain sensitive areas, we should be decreasing the amount of farming. And I think we spend gazillions of millions of dollars on working on phosphorus, and just in Vermont, I think in some cases it would be better off purchasing the land and put it out of agricultural use.
If we could make this our final question, that would be awesome. And I want to thank everybody for staying on as long as you can. And I welcome Kelly and Oliver to finish up your remarks, please.
Great. I mean, John, our subject was on, increased protections for these lakes and some of the tools, and obviously there's connections between land use, agricultural land use, as you mentioned, and water quality in lakes. So I think your points are well taken, and it's part of our ongoing internal dialogue and discussion at DC about how to, meet our goal of restoring, enhancing, protecting Vermont's waters, needs to have those points considered strongly as part of our thought process and action about what we should be doing. And the ANR does have a buffer policy out there that could form the basis for something with more teeth. But the legislature has not seen fit to do that, and so we use this piecemeal approach through different permitting requirements and programs to do what we can these days with supporting, incentivizing, and cajoling, and in some cases requiring vegetative buffers around streams. And hopefully we'll be able to do more if we can demonstrate that there's that connection, which I think is clearly there. So I'll stop there and see if Kelly has any final remarks.
So the last thing I would just like to leave everyone with is just that, I know I presented to you, we're all getting bombarded by bad news, from species extinctions and climate change and all of these things. And I'm just saying, hey, here's another thing to worry about. We're losing our highest quality, clear oligotrophic lakes, state, national, and regional scale. But the good news is that we have been successful at stabilizing phosphorus trends and actually improving them and reducing them in our highest nutrient lakes. We have the tools we need. We can do this. We can turn these trends around. And I think in Vermont, if it's going to happen anywhere, I think Vermont's the place where we can make it happen. And I just want to leave people with some glimmer of hope that those impaired waters show us that if we just put our minds to it, we can turn these trends around.
Awesome. Thank you so much, Kelly, Oliver, and everyone else who stayed on for a few extra minutes. We had a really good discussion going. Yeah, feel free to reach out if there's any more questions. I'm sure Kelly and Oliver would welcome further questions. Awesome. Thank you so much, everyone, and have a wonderful evening.
Thanks for your time and answering questions. Bye now.
Bye.